In this lecture, we're going to discuss about finding the standard deviation when your data has already been grouped for you, i.e., the data has already been placed into equally spaced bins. So the data set that I have here is the one where we had sampled 30 males from the city of London, and they have been binned in intervals or bin sizes of 5 centimeters. So we notice that there are 5 males falling in the range of 165 and 170 centimeters. Now, in the previous video, we did look at how to compute the mean height of these 30 males if we did not know their exact or the exact height of all 30 males, but were just given group data as such. And the way we found the mean, or the sample mean I should specify, was the sum of all the frequencies multiplied by the heights divided by the sum of all the frequencies. And because we don't know the height of the 5 people that fell in this bin, what we had done was we assumed that all 5 of these males had a height of 167.5 or the midpoint of this particular bin. So we multiply 5 times 167.5 to get 837.5 plus 1207.5 plus 1420 plus 1095, so on and so forth, to get a sum of 5315. And the total frequency, or the total number of males sampled, is equal to 30. And we had seen that this was equal to 177.2. Okay. So just like we've been able to calculate a mean in spite of not knowing the exact height of the exact height of the 30 males that we had sampled, we can do the same thing to calculate its standard deviation. And let me write down the formula for computing the standard deviation of heights when your data is already grouped into bins. And this formula will be the sum of the frequencies times mi minus x bar squared divided by n minus 1. And obviously, we need to take the square root of all of this. So we know what the frequencies are. Mi stand for the midpoint of a particular bin, and x bar is a sample mean that we have found up here. In our case, 177.2. So let's apply this formula. Applying this formula to our data set, for the first bin, we have 0 frequency. So the first term ends up being 0. In the second bin, we have 5 frequency, or frequency of 5. The midpoint is 167.5. And that midpoint deviates from the mean of 177.2 by this amount in the brackets. Or 167.5 minus 177.2 is how much 167, or the midpoint, deviates from the overall mean. And we square this. And we do the same thing for the second bin, or the third bin rather. The midpoint, or the frequency first and foremost, is equal to 7. The midpoint is 172.5, and it deviates from the mean by this amount in the brackets. And we do the same thing for all the other bins. So I'm just going to write the last term in this series here. The last bin that actually has a data point is the bin that contains these tall people between 190 and 195. There's only one of them, so 1 times the deviance. The midpoint is 192.5. We take away the mean of 177.2 and take the square of that. And all of this sum gets divided by n minus 1. There were n equals to 30 males that were sampled, so n minus 1 is 29. And finally, we take the square root of all of this. And if we compute what's in the inside, we get square root of 46.44 Plug that into a calculator and we'll get a standard deviation of 6.81 centimeters as such. In fact, I also calculated the exact standard deviation or exact sample standard deviation without obviously having the data grouped into bins, and that number was 6.59 centimeters. Okay. And let's just go back and load that data. So there you have it. If I were to, these were the original heights of the 30 males that we had sampled, and if I calculate the standard deviation using the first formula that we have seen, which is S is equal to the sum of all the deviances, all the heights, how much they deviate from the sample mean, squared, divided by n minus 1, and take the square root of everything. And that value ends up being 6.59, which is not that far off from the estimate of the sample standard deviation when we had computed it using the grouped group data or the histogram data or the frequency data table.